Hi guys, welcome back. Let's see how you did so far. So again, it asks you to use your Pythagorean. So that's the keyword right here. And also at the same time, anytime you see a right triangle or a right angle box here, you always want to use a squared plus b squared equals c squared when you're trying to find your missing length. So again, identify that the 13 right here is your hypotenuse. So put 13 here. The leg here is these two, so x squared plus 12 squared. X squared, that's what we're trying to solve. 12 squared is 144 equals 13 squared, 169. So because we're solving for x here, so we need to get rid of that 144. So we subtract 144 both sides here. So now you have x squared equal 25. And then to solve it, we have to square root both sides here to get rid of that square. But when we square root it, both sides here, you get plus and minus. So you have x equal plus or minus 5. But because we're talking about a length, it can never be negative. So x equal 5. So that's your answer. Let's try it again. Take a look at this. Again, it's the right triangle. And then same formula, Pythagorean, a squared plus b squared equals c squared. So put it in, 6 squared plus 8 squared equals x squared. This right here, 6 times 6, 36. 8 times 8, 64 equals x squared. These two are like terms, so that add up to 100. And then to solve it, you have to square root both sides here to get rid of that square. Again, you get plus or minus when you square root both sides. The square root of 100 is just 10, plus or minus. Because we're talking about a length here, it can only be positive. Yeah. Alright, so let's take a look at example 3. What relationship do you notice among the coordinates of point A, B, and C? Well, if you look at A and B right here, they're on the same level right here. So we know that the y coordinate of the A and B, point A and B all the same. So again, you can notice right here, this half 2 and this half 2. So if you look at this, it's going to be a right triangle, but just notice these two are the same. If you look at B and C here, notice that they both have 8 here. So we notice that the x coordinate of point B and C all the same. So again, if you look at these 3 points, they form a right triangle. And I guess that you want to point out that this corner of this right angle, you can find the corner of that corner easily if you're given those 2 points. Okay. Alright, let's take a look at example 3. This time we're going to learn how to create a distance formula. So let's say they gave you 2 points here. All you have to do is just make a nice right triangle here. Now, according to this, you have these 2 points, visualize the point drawing right triangle, so here we are. And what are the coordinates of a point at the vertex at the right triangle, right angle of a triangle? So right here. If you look at the last example, example 3, you'll notice that this point right here, they have the same x2. Same time, they have the same y1. Again, it makes sense. To go here, you have x2, so you go right x2 here to get up here. Same time, it can only go this high, y1, so right here, y1, this high here. Okay? So now we gotta find the expression for horizontal here. So let's see. We need to find an expression of that. Well, we can do the distance. We can find the difference between these two. We know that these two numbers going to be different. So we know that x2 minus x1 will give us the length of this. So right here it will be x2 minus x1 right there. y1 minus y1 is going to be 0, so that does not help us. The only difference we find was between the x coordinate. So that's for horizontal. Now the next one, we're looking for the length of a vertical leg. So the vertical leg here is this one here. If we look at it, we have the same x2, so if we subtract it, it can be 0. But y2 minus y1 is going to be different here. So that y2 minus y1 will definitely tell us how long this is. If we look at like example 1, example 2, you can see the same thing that we did. So nothing changed. It's just that we used variable here. So now we got to find out this missing length here. Well, let's start to talk about a right triangle. So we know that we're going to use a squared plus b squared equals c squared here. That we're going to use a Pythagorean here. Okay. And let's plug it in. This leg here, let's do this one here. So this is my leg. The length of that is just x2 minus x1. Because we're squaring it, we don't need the absolute value of this. Okay. So. Okay. Plus the b right here is the vertical one right here. And again, because we square it, we don't need the absolute value of that. So it should be y2 minus y1 squared. Equal, well, the c is the hypotenuse, but we don't know what this is. So let's call this d here. Okay. So that's going to be d squared. Now, because we want to solve for d here, and we did Pythagorean, but we want to solve for d, we're going to have to rearrange it. So if I want to solve for d, I need to get rid of the square here. So let's go ahead and square root the whole thing here. So let's square root the whole thing here. x2 minus x1 squared plus y2 minus y1 squared. We square root this. This cancels out. That's what we want in the first place. So now we end up with d equal right here, which is switch around the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's the formula for finding distance. And we don't need to put plus or minus here because we know that the length of this triangle right here, that's all going to be positive. So we just keep that in a positive form. Okay. So let's use that. Okay. This is the formula. So you want to make sure you know how to use. Okay. So use the distance formula to find the distance between the point with the coordinate 3, -1 and -1, 2. So this is going to be my first point. So let's label that x1, y1. That's my first point. This is going to be my second point. So x2, y2. And since they want us to use the distance formula, let's go ahead and write that out. D equal the square root x2 minus x1 squared plus y2 minus y1 squared. Now it's just a matter of substituting in correctly. So square root, we have x2 which is -1 minus 3. Okay, so we can put this in parentheses if we want, but I'm just going to keep that separate. Just to make sure you know that you have that minus thing right here. That's all going to be there unless you change. Okay, plus y2 here is 2 minus y1 here is -1 squared. Okay. Now let's go ahead and simplify this. Here we can do it easily. Here you should notice something here. What do you notice about this? This one should become positive. So let's go ahead and change that so we don't get confused. Yeah. Now we go ahead and do what we need to know. Negative 1, negative 3 together, that gives you negative 4. 2 plus 1 right here give me 3. Negative 4 squared right here give you 16. Because negative 4 times negative 4 becomes positive, so that'll give you 16 here. 3 squared give you 9. 3 times 3 is 9. Combine them together, no more square here, so we have 25. And what's the square root of 25? Should be 5. Once you do the square root should not be there anymore. You complete that action already. So the distance between that 2 points is just 5 units here. Okay. So what I want you to do is go ahead and try the next problem for me. And if you think you got it, great, move on to the next one. If you not sure, then have your teacher take a look for you.